Good morning. Uh, in today's session, we will talk about force between parallel currents, and we will see some problem based on it. Explain with reason. Explain with reason. Explain with reason. In which direction does the current flow? In which direction does the current flow KLMN move when kept near infinitely long straight wire carrying current as shown in the figure. Carrying current as shown in the figure. Okay, so now I'll give you the figure. We have a square loop which carries current, and KLMN is the loop. Explain with reason. In which direction does the current loop KLMN move when kept near infinitely long straight wire carrying current as shown in the figure? Now here first we know when we have two parallel currents, there exists a force because of the field produced by these currents, we have some forces. Now first consider this KN, okay, the side KN. When you see this side KN, the current, you may consider this current as I1. The currents are in opposite direction, and when the currents are flowing in the opposite direction, we know that the force between the two conductors are repulsive in nature. So this force will be acting like this. I can say that F1. Okay, so now the force on the line LM, what will happen here? On the side LM, the force is the current is downward direction, and through the wire is also it is downward direction. So when two parallel currents are in the same direction, the conductors will experience an attractive force. So the force here on the side LM, it will be acting towards the conductor. This is F2. So two forces are acting like this. Now which force is greater? So the conductor, the loop will move along the direction of that force. Now because the Kn is nearer to the conductor, F1 will be greater than F2, and hence the loop will move away from the infinite current carrying wire AB. Now we'll write down these things. Consider side Kn of the current loop. Consider side Kn of the current loop. The current flowing through Kn and through the straight wire are in the same direction. So the force F1 acting on Kn is as shown in the figure. Because why? Because the currents are sorry, no, not in the same direction. Sorry, I'm very sorry. So here it should be in the opposite direction. In the opposite direction, not in the same direction. Opposite direction. So remember this, it is in the opposite direction. Okay, so right here clearly. So consider side Kn. Consider side Kn of the current loop. The current through Kn and through the straight wire or in the opposite direction. Hence force F1 will be acting as shown in the figure. Because the currents are in the opposite direction, the force is repulsive in nature. So towards Kn it will be acting away from the wire. Now consider side Lm of the current loop. The current through Lm and through the straight wire are in the same direction. Hence force F2 will be acting as shown in the figure. Because if currents are in the same direction, the force is attractive in nature, or the force towards will be acting towards the conductor. Consider side Kn of the current loop. The current through Kn and through the straight wire are in the opposite direction. Through I1 it is downward, through Kn it is upward. Hence force F1 will be acting as shown in the figure. Consider side Lm of the current loop. The current through Lm and through the straight wire are in the same direction. Hence force F2 will be acting as shown in the figure. Now F1, the side Kn being closer to the conductor, F1 will be greater than F2, and hence the current loop will be moving away from the infinite current carrying wire. Side Kn is closer to the current carrying wire. Hence F1 is greater than F2, because if the two parallel currents are nearer, the force will be more, because in the equation we have the force is inversely proportional to 1 by force is proportional to 1 by r, or inversely proportional to r, the distance between the current carrying wires. Hence F1 is greater than F2. Therefore the current loop move away from the infinite current carrying wire. Infinite current carrying wire. Okay, so hope you understood this, important here.